Hello, everybody. My name's Tony Sarathchandra. I head up Contrail SD-WAN, SD Branch Product Management. And today, we're also joined by Snehansu, Technical Marketing Engineer on our team. And we're going to give you a quick overview of our solution and some of the customers and the use cases that we have been focused on for Contrail SD-WAN. You obviously heard earlier today a little bit about the Mist technology, and this is kind of playing off that and how this kind of integrates to our overall AI for enterprise architecture and vision. So just in terms of the agenda, I'm going to cover about 30 minutes or so of solution overview, give you guys a chance to sort of ask questions, and I'd like to keep it interactive, so please do ask me questions. Give you a solution overview, and then Snehansu will use the bulk of the time, sort of give you a view of the actual product. Live demonstration, no recorded videos live, so fingers crossed everything will work. Hopefully the hotel Wi-Fi will be good, and then of course we can take more questions during the session as well. So that's kind of what we have planned for you. So unless there's anything else, we'll dive right in. So the first thing I wanted to cover is the customer and use cases for the solution. We've had the solution in market now for well over 2.5 years. We've garnered a number of marquee customers, and we continue to garner additional customers in the industry. The first thing I want to kind of emphasize is that the solution is built around our installed base of over 1 million SRX devices in the field. SRX is our security branch portfolio, so it does both routing and security. We've had this product in the market for well over 10 years, going back to the NetScreen acquisition, if you guys are familiar. So it's evolved over time, and today it runs full Junos with full L7 security. And what we've done is we've really taken the portfolio to the next level by implementing SD-WAN functionality on these platforms as well. So from a customer perspective, the first point I want to make sure that the folks in the room, as well as who are listening in the live feed, get across is that if you're an existing Juniper SRX customer, it's a very easy way for you to potentially move over to the solution that we will be presenting later in the session today. In a lot of cases, the current equipment may already meet these needs. The second thing is that we have garnered a lot of new SD-WAN customers, and I'll be talking about a few of these here in the session later in the deck. But anywhere from top-tier Fortune 100 type customers to retail customers to manufacturing customers to also managed service providers such as, for example, Vodafone, as well as system integrators like IBM, for example. The bottom of the slide just kind of shows a recent quote of a customer that we just won out of Australia. They're sort of a bread-making company. They do bakery products. And they had about 20, 30 sites, and they decided to go with Contrail SD-WAN solution because of the extensibility from the branch to the cloud. So this is kind of a snapshot of the customer. So let me kind of double-click on one such sort of partner, and in particular IBM. And IBM here at the Nextwork event today is one of our sponsors, and we'll also be presenting a couple of sessions if you are actually attending the event. So I would encourage you to go see that. But IBM has a service called Network SD-WAN. It's actually called SD-WAN Network as a Service. And they utilize the Contrail SD-WAN software within their SoftLayer data center and offer a managed SD-WAN solution using their global network peering platform called GNPP. And this is a managed offering that is available to enterprises globally today. So let me sort of double-click a little bit and explain to you what it is that they're doing specifically with the platform. If my clicker was going to cooperate. There we go. So the first thing is within IBM, they have a couple of key components. The first is they have the orchestration and the management platform within SoftLayer, as I mentioned. That's number one. And this is a multi-tenant solution. So a single controller/orchestration engine for SD-WAN can handle multiple enterprise customers from an IBM perspective. The second thing is they have a set of gateways for terminating the SD-WAN endpoints. And these are multi-tenant gateways. And this is one of our key differentiation. If you're familiar with other SD-WAN solutions out in the marketplace, you typically have to deploy a gateway per tenant. And our gateways are multi-tenant. So in this particular case, IBM has deployed a multi-tenant gateway or a set of gateways within their GNPP infrastructure to host multiple enterprise customers. The third aspect is the endpoints. And the endpoints are the SRX portfolio and the NFX portfolio. And the differences, and I'll go into that later in the session, whether you want an integrated security, all-in-one routing device, or you want a much more of a flexible sort of x86 UCP-based device. And we offer both where, for example, you can run KVM-based hypervisor VNFs on the NFX platform, whereas on the SRX, it's integrated JUNOS only with SD-WAN. And then they have a secure overlay management across their management networks. And then they offer a set of VNFs. So they offer, obviously, Juniper services, but they also offer third-party VNFs from some other vendors. So for the end customer, it's best of both worlds. So they don't need to perhaps throw away their legacy network functions. They can, if the networking vendor offers a VNF, for example, a very common VNF that we see is WAN optimization. And in fact, we have a partnership with one of the key WAN optimization vendors out in the market. And that is an integrated solution that you can deploy with Juniper SD-WAN at the edge of the network. And then they also provide the fifth component, which is a complete NOC and SOC capability, where it's monitored 24/7. There's trouble ticketing and SLA management and things of that nature. So this is kind of what IBM has done, and this is a fully production service now that they're deploying customers globally. And some of the customers I showed in the previous slide were actually on that platform as well. So the next customer I want to kind of dive into is Vodafone. Vodafone is a multinational service provider, obviously known very much for their mobile presence, but they also have a very strong fixed wireline presence, particularly in Europe and other parts of Asia and Australia and New Zealand. And Vodafone is a customer that we were working for a long time through an RFP process, and they selected Contrail SD-WAN back in sort of late 2017, early 2018. And they decided to go with Juniper in particular for the following reasons. The first is that the solution that we have enables SD-WAN to be truly integrated with existing IPVPN services. So if you're a managed service provider who sells IPVPN, which is typically their bread and butter for connectivity, as customers migrate to SD-WAN, it's kind of an imperative that you have to have sites on your IPVPN and sites on SD-WAN, and that those sites have to communicate seamlessly with each other. So the solution effectively enables that. So we have a full hybrid MPLS interworking solution because our SD-WAN gateways actually can peer natively with BGP and MPLS into the IPVPN backbone, effectively interfacing with your provider edge equipment. The second sort of key differentiator here is that every endpoint comes with full built-in LTE or 4G connectivity on the Vodafone network, as well as the virtual firewall. So virtual firewall is a key characteristic of our solution, as I mentioned, because it's built around the SRX portfolio. So customers who get the Juniper solution get the firewall day one as part of their intrinsic or SD-WAN solution. And so this is particularly important, and you'll see that throughout the session, that when you're terminating internet circuits, you almost always have to have a firewall. And not having a firewall in today's in security environment is not an option. So having that virtual firewall is a key differentiator for us as well as for Vodafone in this case. And then thirdly, they've done some additional capability to do sort of bandwidth on demand. And this is something they've done through customization of our API system. And Snehansu will show some of that, where we have the ability to basically create templates and allow custom UI-driven menu options for the end tenant to basically perform specific functions. In this case, the tenant can come in and say, hey, I want 100 megabits, or I want 1 gigabit at a particular time of day, and the speed kind of fluctuates and changes based on that setting. And that's something that we built specifically with them for that service. So this is all in production as well. You can go in and have a look at the Vodafone Ready Networks SD-WAN site. There's a sort of a QR code there if you're interested in getting more information around the service. Of course, we have many more customers, but I want to kind of start off by giving you a flavor of some of the key customers we have that are currently deployed in production. So unless there's any questions, I will go into the solution overview. Any questions so far? No. Okay. So Contrail SD-WAN is key in terms of the following differences. Firstly, we have unparalleled scale. We scale in excess of 10,000 endpoints per single cluster of controllers. And because we are multi-tenant, we can carve that 10,000 across many, many different tenants. No solution that I'm aware of from any vendor out there today scales to this point that have been tested. And we did this test with ENTC, sort of fall of last year, and the report is available on the ENTC website. The second key aspect here is the simplicity of the UI, and you'll see that in the demo that Snehansu will do later on, because if you compare sort of SD-WAN 1.0 vendors, and I've seen a lot of those, and I'm sure you have as well, the UI is very clunky. There's bazillions of options to tweak this parameter and that parameter. And what we really focused on is reducing the complexity, simplifying the workflow, and making it easy for the user just to enable their sites and get up and running. The third key difference and differentiator here is the range of endpoints, both physical and virtual. So we have from, say, the low-end SRX sort of 300 all the way to the SRX 4200 and the 4600, which are 10 and 40 gig capable. And this is 256 AES encrypted throughput numbers. Okay, the straight IP throughput for IMIX is much, much higher. So it gives us ability to scale in very large, complex environments, which is something that some other solutions struggle to do. Security, of course, as I already mentioned, is fully integrated into the solution. It's not an afterthought. If you look at, for example, a lot of the new security vendors that are also proposing SD-WAN in the market, is they have very basic SD-WAN, but the SD-WAN functionality is not integrated with security. And the two doesn't work together cohesively in tandem. That is not the case with Juniper's Contrail SD-WAN. Every endpoint can be fully secured with the full set of L7 security policies, whether it's UTM, NGFW, ATP, IDS, IPS, etc. So we provide what we call SecIntel for the WAN, and then we also extend that onto the LAN infrastructure behind the endpoint as well. We provide clustering, where for high availability, we can run dual CPE in HA mode, which is active-active, with multi-homing options across multiple endpoints, so that for redundancy and failover, you have always on network when it comes to SD-WAN. And then lastly, we provide choice. We are able to deploy on-site for large customers, also for certain federal or other types of government customers who sort of insist on on-prem deployment, or for smaller customers or customers that want to just simply consume it from the cloud, we offer as Contrail SD-WAN as a cloud service natively as a SaaS offering starting Q2 of this year as well. So these are the key kind of best capabilities of Contrail SD-WAN solution from Juniper. So let's kind of switch gears and talk about why this is the case. So one of the things we focus on is easy out-of-the-box experience, as I mentioned. So as I think from the previous session that Sudhir and Bob talked about around Mist, we focus on easy out-of-the-box experience, end-to-end from configuration, onboarding to monitoring to management. Right? So ZTP is part and parcel of all the endpoints. You can upgrade the endpoints completely. You can manage them in a group level. You can set network-wide and enterprise-wide security policies and get alarms and events across the overall enterprise. The software is built around a cloud services architecture. It is fully microservices based. So whether you're a small enterprise that's looking to maybe deploy 100 sites or less, or a very large enterprise that has thousands of sites, or a managed service provider, as I mentioned earlier, the software really scales up as well as scales down. We have open APIs, both southbound. We use netconf over SSH and XML on the southbound side and BGP for control. And on the northbound side, we are fully REST API based. So everything you do through the UI, you can drive through the API as well. And then lastly, I would say we're one of the very few handful of SD-WAN solutions available in the market that is truly multi-tenant. We're multi-tenant in the management plane. We're multi-tenant in the control plane, because we use a single controller to manage multiple tenants. We use multiple protocol BGP to do that. And then we also multi-tenant in the data plane, where the gateways themselves can be multi-tenant, and we have traffic separation through multiple VRFs in the data plane on the SD-WAN gateways themselves.
So I want to ask you about that, because I understand the multi-tenant control plane, right? That's I won't say it's a table stakes, but there's a lot of people doing the control plane multi-tenant. What do you mean by on the endpoint? Because I'm not going to say everyone, but a lot of people are doing differentiated services based off of different overlays. Mm-hmm. And you're saying you're the only one who's doing it. And so it's a VRF, right? Ultimately, when we get down to it, it's a VRF and tunnels.
It's a VRF, but what we do is a single device can, and I'll talk about this later in the session, can be run in sort of a single tenant mode, where the whole device is dedicated to that one tenant. And you can still have multiple VRFs within that device for the same tenant. Or the controller can manage the same device and partition it across multiple tenants, where the VRFs are only visible to the individual tenants and the rightful owner of those VRFs. So there
like a virtual device.
Yeah, so there the gateway is actually owned by the service provider or the managed service provider, typically who's managing multiple tenants. Right? So like you saw the use case IBM that I mentioned earlier. So the gateways are therefore managed by IBM, but the actual tenant VRFs are unique per individual tenants that are hosted on those devices.
Are you doing that through like VNFs? Like how are you separating that?
Yeah, we're doing
secret sauce.
Yeah, we're basically doing it through MPLS technology, which is inherent in Junos through BGP and MPLS. So every tenant basically gets a VRF context, and traffic is separated at the VRF level.
Okay, I'm still a little confused, and I won't harp on it. I'm just going to ask it.
Okay.
You said it separated the VRF level, but VRFs are only available to these individual contexts. How are you splitting contexts? Because a VRF is available to the entire device, and you're saying that this VRF somehow is uniquely available only to a particular tenant, which means you would need to split not only the VRFs, it's not just MPLS, it can't just, I'm having a hard time understanding what it is you're saying. Maybe I'm
so maybe Snehansu can talk to it. Do you want to?
Yeah, maybe I can explain. For example, let's say there is a provider device and there are multiple branch sites which are connecting to the provider device. Okay, so that is the common device. because the provider is now sharing this device for multiple different enterprises, and multiple different enterprises do not want their data to be going over the same channel. So that is where the IPsec or the other tunnels, they actually terminate on exclusive VRFs for that tenant. So the system takes care of the fact that, for example, enterprise A has a VRF A, whereas the enterprise B goes over VRF B and terminates on the gateway in order to reach out to the MPLS network or the internet.
So think of, if you're familiar with L3 VPN, we've implemented L3 VPN on top of a IPsec overlay, right? So basically, the controller goes and creates these instances across the gateways, as Snehansu said, that are unique per tenant, and the only persons that have access is either the global admin or the specific owner of those VRFs. Yeah.
Okay.
Yeah.
Okay. Thanks. All right. So part of our broader strategy here, however, beyond SD-WAN, is to move towards the AI-driven enterprise. And so here, what you see is that we've started sort of with secure router and hybrid WAN and SD-WAN. That's going to be the focus of most of the conversation today. But where we're really going is the SD branch and the SD campus vision. Where the SD-WAN technology is getting more integrated with the LAN piece as well as the Wi-Fi piece that you saw earlier in the session today. And we're going to wrap this all around Marvis, which provides that service assurance layer that that you saw earlier, that provides the full AI capability for WAN, LAN, and Wi-Fi, right? So that's kind of the broader vision, but we're going to focus on the SD-WAN and SD branch story for this particular session. So how does this all come together? So here it's kind of a holistic slide, and what you see here is you have the controller in the middle that can be either on-prem or cloud delivered. You have your end devices, right? That could be your WAN routers or your switches or your access points, as mentioned earlier. Here are the gateways and the hubs that we just talked about. And these typically sit within a data center or a POP in the case of a managed service provider. And then we also extend into public cloud, whether it's Amazon or Azure. We have endpoint support, and then we also support breakout into cloud security services that are common, like Zscaler. So where the customers want multi-cloud connectivity from their enterprise or back into their private data center or to their enterprise branch sites, the solution provides full end-to-end connectivity for the end users. And of course, I should have mentioned that we support this across any type of transport, and we'll talk about that later. But one of our key other areas of differentiation is that we not only support Ethernet or LTE, but we have a myriad of other sort of physical interface support on our CPE devices as well. So the components, just to kind of double click on it one more time, is the controller, the endpoints, and that can be both physical or virtual, right? The physical is the SRX and the NFX platforms. That comes in various feeds and speeds and different sizes. And then we also support the VSRX, which is available on Azure and Amazon Marketplace. A set of gateways that basically consolidate the endpoints into an aggregation site. And then the other associated endpoints on the LAN as well as in the Wi-Fi system. Okay, so those are kind of the key components of the Contrail SD-WAN solution. So the other key thing I want to also kind of touch on is, Q2 we launched this as a native SaaS service, and this was something that a lot of our customers have been asking for, because even though, as I said, we had a very robust and scalable system, customers wanted to consume it in a much more easy fashion, particularly for the smaller size of customers. So we introduced this in Q2, so this is in full production. And what we provide is a native SaaS service, which is multi-tenant, and this is actually what Snehansu is going to be demoing. There's specific SLAs around it, where Juniper actually runs the infrastructure, and we give you access to the controller to allow you to manage the service. We don't manage the service. You manage your network. We provide the capabilities for you to do that. We provide disaster recovery, compliance, and horizontal scale software upgrades and things like that are fully taken care of. So you as an end customer, you don't need to worry about the headache of deploying the software, upgrading it, maintaining it, things like that. It's all taken care of for you. Okay. All right, so let's double click into a little bit more detail. Okay, so that's kind of the overview of the solution. And how are we doing for time? Okay, I'm a little bit late. I'll speed up. Let me cover some of the specific use cases. There are 3 use cases that Contrail SD-WAN supports. First, we support a standalone next generation firewall. So if you have an SRX device that requires management, we can just manage that from the cloud today without any SD-WAN whatsoever. We also support EX and Mist behind the SRX firewall. The second use case is the typical SD-WAN, and you see the overlay tunnels and the hub on the right-hand side of the picture. And this is one that we'll be focusing on primarily today. And then the third use case we support is a standalone switch management as well. And that is possible perhaps behind a third-party CPU device.
So I do have a question for you on the SRXs.
Mm-hmm.
Obviously, these are standalone firewall devices that have existed for some time. They have their own configurations. They're locally managed.
Yep.
This has been a challenge in maybe some other implementations that you compete against when it comes to, what do you do with that? So are you running the same version of Junos that you always have, and you're just managing it? Mm-hmm. And then how does that affect things like, do you have a zero-touch provisioning for an SRX, or is there a manual process that has to happen?
Yeah, that's a great question. That's a question I get asked a lot, actually. So we have if you have existing configuration, as you would for brownfield, we have a process where you can bring that into the system and make it part of the automation framework by creating a template. So we have a tool called a config designer that allows you to templatize your existing config. Basically, things that you want to automate as part of the initial activation process, you can include as part of the template. And these may be things that may not be there in the standard workflow within the NG-FW provisioning setup, right? So that's a very common. In fact, we were dealing with a customer just last week who has out-of-band, management interfaces configured for disaster recovery and configuration, right? So they wanted in-band management, but they also wanted out-of-band management, and so we were easily able to set that up using these templates. So once the templates are there, the device provisioning is fully automated, so you're back to your kind of previous brownfield config that you had in the device before you introduce the controller.
So there is like a switch that gets flipped when you go from independently managed to controller managed. When the template is there, it then takes over configuration.
Correct.
You still have visibility into, can you log onto the box? And you're looking at commands and kind of getting status and whatever.
Yeah, absolutely.
And does all management then need to happen then from the controller?
Yeah, so typically, if it's controller managed, you need to do adds and changes through the controller. Mm-hmm. We do not recommend doing changes directly on the device.
Can you though?
You can, but we do not recommend it. You can get into trouble doing that.
Of course.
But we would recommend it doing through the controller, but you have full direct access to the CLI, of course. And we actually initiate that directly from the controller, where you can create a CLI access through SSH tunnel.
All right.
Mm-hmm. If it detects a change, it'll automatically put a thing in there saying you voided your warranty.
Is that what it is? And then for Greenfield, I'm rolling out a new SRX. Mm-hmm. What does the onboarding process look like? How do I get it attached to the controller?
Yeah, so out of the factory, if depending on the age of the device. From a certain point on, the software actually comes in pre-programmed to call home a specific well-known address. So as long as you have an internet connection and you plug the device in and you get an IP address, it'll call home. It'll connect to what we call the redirect server. Based on the serial number, it'll basically resolve itself to the rightful owner. And then within the controller and the provisioning steps will automatically kickstart at that point.
You maintain the list of serial numbers to customers and where that controller exists. That works both in the cloud and on-prem?
Yes. Works both in the cloud and on-prem. And in the on-prem version, the on-prem controller talks to the sort of global sort of DNS system, if you will, that resolves the serial number to the owner.
All right. Yep. Thank you.
That could be a lot of fun for those 5-finger discounts that end up on eBay.
Yeah. I mean, we're seeing this everywhere. Like, I mean, that's a pretty common model, right, in the market.
Yeah.
But yeah, you're then, that service has to be online for those things to come on for the very first time. That's
correct.
The only time
that's correct.
Yeah.
That's correct. It's usually one time for device activation. It's not required. So here's kind of a slide that shows all of the features that we have in Contrail SD-WAN. I'm not going to cover these in depth, but touch on a couple. But what you're seeing here is that we have a whole host of best-in-class SD-WAN and SD-branch functionality. We have full L7 security functionality, as well as functionality that is specific for managed service providers, like obviously scale, as well as multi-tenancy on the gateway and the controller that we've talked about. The other thing that's key is we have very robust and deep role-based access controls, so that if you are deploying it in a multi-tenant configuration, you can create these roles and use this against Snehansu. We'll talk about these in more detail. So in the interest of
back to that for just a second.
Okay, sure.
Because you kind of opened the box on it a little bit.
Okay, did I?
Having all of your security things there and highlighted in terms of what it is that you do, is that just for meaning that you support us to be able to push out profiles that way, or that you as the cloud offering are going to be offering, best of breed or, professional services level or something as far as pre-done templates for that?
So today, for security, we just provide you the mechanism to provision your policies. We don't tell you what the policy should be. That's really up to you to decide. But our PS team can certainly help you and guide you if you need that level of guidance. But that's not part of the system. The system just gives you the mechanism to implement the security policies and push them across your enterprise network.
Okay.
Yeah.
Yeah, and it's actually intent-based policies, both for security and SD-WAN. It's technically so easy that I guess any IT admin should be able to do that very easily.
So easy that even Stefan can do it?
Everybody can do it.
You could try, yeah, absolutely.
I'll show that.
Well,
Yeah.
It's 4 JNCIAs. I figured it'd be
just
okay.
4, yeah.
All right, so let me, however, highlight some of the key areas in that feature list, just in a little bit more color and detail with the remaining time here. The first is we have a very sort of sophisticated capability called dynamic meshed SD-WAN. And you might have heard, a lot of SD-WAN vendors out there, talk about full mesh and hub and spoke, et cetera. And when we looked at this problem, we said, well, neither of those answers is necessarily the right solution for a given customer, because a customer traffic profiles varies significantly from customer network to customer network. So what we did is we came up with this controller-based architecture where the controller is able to actually learn the traffic patterns of the enterprise network. It initially starts off with a hub and spoke model, right, where every spoke is connected to at least 1 or 2 hubs, right? But over time, if specific sites are communicating between each other, the controller recognizes those traffic patterns and is able to set up direct site-to-site tunnels to mimic and shortcut the traffic direct site-to-site. So what this means is that the overlay network basically self-adjusts to the traffic flow of the actual enterprise over time, right, and optimizes the overlay based on the actual traffic pattern. It also, when traffic is not going across a specific set of tunnels for a specific time, it can tear down the tunnels as well. So this is what we call dynamic mesh SD-WAN, which is, we believe, an order of magnitude more efficient than a full mesh design that typically you find, which has all sorts of scaling and peering issue problems, right? And the routing is automatically done through BGP, so when the shortcut is established, the application is completely transparent to the application.
And that's all orchestrated by the provider hub.
It's all orchestrated by the controller.
And what happens when there's no access to the controller?
So when the controller is not reachable, the current routing infrastructure continues to function because we actually can run in headless mode up to 180 days without a controller.
But does it use the last node?
It uses the last.
Default back to never mind.
No, it uses the last node. So basically, if you had a set of reachability and routing tables to get to the next endpoint, if the controller goes away, the last set of known routes will remain in all the endpoints to ensure that traffic continues to flow uninterrupted in the data path.
So in the event of a natural disaster where the controller is knocked out and site 2 is knocked out, and site 2 needs to come back online, but the controller is not online, how does it get around something like that?
So for bringing up a new site, you do need the controller back online, right?
We'll be bringing an existing site back online.
So bringing the existing site back online would
Existing sites are actually talking to the enterprise hub or the provider hub or both of those. So those will work. The management will not work.
Okay.
So once it's already provisioned or configured, when we say provisioned, it means configured, essentially all the routing information resides on the device itself. So the tunnels and all, whatever needs to re-establish, or the IK sessions or anything that needs to be re-established, it will automatically re-establish. So it will just show that the management is down.
Yeah, and we've actually tested this because a lot of our customers have asked, like, what happens when the control goes away? We've tested this extensively in our testbed environments and shown that traffic continues to run uninterrupted, for over 180 days. And there's a specific timer that's over 180 days that ensures that is the case. So that's why I say that.
And I have two questions on this before we proceed.
Sure.
First is this topology configurable? So if I want to run a full mesh, can I force it into that? Or if I want to run a hub and spoke, can I force it into that?
Yeah.
Yes.
So this is just another option?
Yes,
right? Okay.
yes. You can absolutely do that.
For this, what is the lag time between recognizing that traffic is going site to site to the time that a tunnel is stood up?
Yeah, so it's kind of a lazy setup. And tear down, it's not like instantaneous because you don't want tunnels going up and down and bouncing across your network. So typically there's a threshold at which point a certain traffic pattern has to be seen in the network for a certain period of time. And usually that's configurable, but it varies from 3 to 5 minutes, right? So these are long-lived flows, right? That you count, site 1 and site 2 is constantly talking and chattering with each other for some period of time, then the tunnel will get established and traffic will get rerouted.
Also, the other thing is the branch sites themselves have a threshold wherein they can say, for example, have X number of tunnels established, and they will actually keep those tunnels. Okay, so only when they cross that X number is that when they will start checking, the controller will start checking whether there is traffic going on between the different sites. If there is no traffic, then it will start tearing down the
so you can set the threshold for tear down to be aggressive or lazy as well. Yeah. So that's configurable as well.
So Tony, my question is, so kind of comparing and contrasting like the legacy way of doing things versus like the new way with like a controller SD-WAN sort of architecture. The old way we would do this like on the SREX, maybe like with group VPN, or maybe as Scott astutely points out, DM VPN on the Cisco world. So I'm just kind of, using this obviously this is a problem we've already solved, right? The hub and spoke versus the N squared problem, and this really takes care of that. But I'm wondering, is there any sort of benefit of this approach, using a controller-based approach versus and the old way we used to do things.
Yeah, I mean, the main benefit is obviously automation, right? You don't need to go in and provision the IKE keys, the IPsec configuration, and every time you change, one site to update the keys on the other sites, all that is done for you. We support PKI-based certificates, so the controller, takes care of, distributing the certificates. We do certificate renewals and things like that. So firstly, it's automation. The controller is also, I think you would have probably figured out, is effectively acting as a virtual route reflector, right? So there's BGP sessions between every endpoint to the controller. So it's basically handling the whole reachability, the IKE setup, and the IPsec, and the overall topology, and that whole set of automation is what really is the primary benefit, where, days gone by, you would have lots of config, right, to do all of that, yeah.
Also, there's a concept called mesh tagging that is there. So say, for example, you have sites which are there, which can actually mesh with each other, but you do not want them to. So you put those in different mesh tags. Essentially, you do not want them to talk to each other directly. Okay, so that can be very easily implemented using the controller and the mesh tagging.
Yeah. So I was not going to go into that here, but yes, since you brought it up, so as you can see, the tags are there. And so what the tags do is it allows you to provide affinity between link types or similar link types through which on opposing sites where tunnels are established. So think of, let's say you had sites with LTE links and sites with GigE links, both each site having LTE and GigE, and you want the GigE links to mesh with each other, and you want LTE links to mesh with each other. You don't want the LTE links to perhaps mesh with GigE because one is going to be asymmetric and not provide good throughput, right? So things like that, and then we support geo-based meshing, so you can assign what we call this enterprise hub, right? An enterprise hub is a concept that is dedicated to a particular customer, and actually this is the next slide here. So we support this concept where, to my point earlier, where we have a hub that's dedicated for one customer, and you can assign tags across the WAN links to enterprise hub so that site 1 and site 2 connect to enterprise hub, let's say on the East Coast, whereas site 3 and 4 connect to enterprise hub on the West Coast. And the hubs themselves can optionally mesh with each other as well. So we have what we call a 2 levels of hierarchical meshing, right? Where you can create an overlay between the sites and the hubs themselves can connect to each other across an overlay mesh, and then that is all provided and automated through the controller. In fact, this slide actually shows that. I think the next slide here shows that. So here what we have is we have a typical kind of hub and spoke dual homed, right, from these regions. And then, you can have direct, oops, this clicker's not cooperating. You can have direct site-to-site tunnels established here based on the on-demand dynamic mesh capability. But let's say you have these enterprise hubs, and customers sometimes want to connect these enterprise hubs through public networks as well. And so you can use public networks for transit connectivity between the enterprise hubs as well, should you not have dedicated connectivity from an underlay perspective, right? So we provide that level of 2-tier connectivity from a topology perspective. And this is fully automated by the controller. No operator intervention required.
Since you had mentioned it as affinity, just command line wise, my mind was going to MPLS TE. Are you doing the same type of thought process as that goes through?
Sorry, did you say MPLS TE?
Traffic engineering tunnel?
So we are doing some basic traffic engineering on the overlay, but we don't do reservation. Right?
Well, no, but as in your gold can talk to gold or silver, but not bronze and things.
Yes, we definitely do that. Yeah, we definitely do that. Yeah, and then the tags allow that to happen as well.
Exactly, it is. Yeah.
So I'm going to speed up because I think we're behind. All right, so.
Quit asking questions. You're making them.
That's okay. We're about 15 minutes behind schedule. All right. Okay, so the other key point here is, so we talked about topology, we talked about sort of all the cool things a controller can do. But really, at the end of the day, the IT administrator and the business really wants to make sure that the applications are performing to what they need to be within the enterprise. And so Juniper's Contrail SD-WAN is really focused on application-based control around SD-WAN. And we do that through basically deep packet inspection of every application coming into every endpoint on the SD-WAN network. And as you know, the SRX has that capability, has had that for a long time. So basically, we leverage over 4,200 unique signatures that are able to be identified. And those signatures are then mapped into specific SLA classes that are specifically defined based on the SD-WAN profile and policy. But what you see here is basically you have a department at a site, specific applications like Teams, WebEx, Skype, Link, et cetera, having a SLA that's labeled collaboration. And we'll see what collaboration can actually map into. We also support custom user-defined applications. So if you have in-house applications that are not easy to define, you can define your own applications and then use that within the SD-WAN policy and make sure that that SLA is provided for those applications. So what is the SLA?
Real quick, when we do that with the custom applications, I know how exciting it is to do that on the SRX. Is that something we configure in Contrail and it pushes it down, or do we have to?
It's all UI driven.
Okay.
It's you define a custom app, and hopefully you'll have time to show it. You can use that in the SD-WAN policy. It's fully automated.
And is that just off like a 5-tuple?
No, it's more than a 5-tuple. You can do regex expressions, you can do protocol types, you can do all sorts of funky stuff.
Mary Poppins.
So I was going to ask, because deep packet inspection can only get you so far.
Meaning?
If you're not decrypting traffic or...
Yeah, that's a good point. So actually...
only 80%.
Yeah. So I think we have the same challenges as I would say a lot of other SD-WAN vendors in that regard. And so for that, we also support DSCP-based. So if your traffic is encrypted, your encryptor can map the outer header to DSCP code points, and we can take the policy on that way as well. Okay, so the SD-WAN policy is basically utilizing a technology called AppQoE, Application Quality of Experience. And basically we provide or insert probes within the data path of the application stream to measure these specific parameters like two-way latency, ingress, egress jitter, packet loss, et cetera. Why do we do that? It provides a level of granularity that is unparalleled because you can actually measure the actual quality of the application versus using synthetic probes. A lot of other vendors in the industry today use synthetic probes to mimic what the application would actually be behaving without knowing the actual behavior or the SLA that the application is receiving. Whereas in this case, the application traffic and the probe traffic are basically integrated into the same flow. And so whether you're queuing or dropping packets or anything like that for that particular application, the probes are going to basically see that, and you're going to basically see those in the SLA violations that are measured. So here are some of the options. Again, I'm not going to cover it in detail. Snehansu is going to do that. But this is one of our areas where we built on top of Junos and the DPI engine that we've had to get to that next level of SLA measurement on a per app basis.
Is there any thought of doing synthetic as well as native traffic?
Yeah, we do synthetic when the links are idle.
Okay.
So if there's no traffic, you got to measure the links. We send synthetic probes for idle links. But when there's actual data traffic, we actually use the data traffic and embed the probes within the data traffic.
So they suck unless you're using them when you're...
Yeah. So it's...
Also, it's like, say, for example, the traffic is going on, say, for example, the MPLS link. And you want to measure the internet link or the other available links at that time. So synthetic probes are actually going on those links also.
That's great to hear. Yeah, definitely the combination.
Yeah,
yes,
we use
synthetic probes. Actually, it's synthetic, but it's not like dummy synthetic. For example, if we have a particular SLA with some cost parameterization for, say, some collaboration application, which is very different from, let's say, some normal other website, which has just some different cost parameter. Okay, so the synthetic probes would also be different. So there would be two different types of synthetic probes running to replicate that to different cost settings.
Absolutely. We also provide very granular breakout options. So because we have application visibility at every point in the network, we can break it out on a per application basis on each site or at the enterprise hub. Or we can, break it out on a department, or we can break it out on a, all traffic destined to, specific, destination, for example. So we have very flexible breakout options, both into the underlay as well as at the enterprise hub, as well as to some cloud security applications, as mentioned earlier. The other benefit that we have is we talked about how we use VRFs in the SD-WAN design. We provide full network segmentation end-to-end on a per-tenant basis using the same concept as well. So we use that within the tenant where we can support 25 or more different what we call departments. And the department could be representative of, say, guest Wi-Fi, your PCI compliant traffic, or your corporate internet traffic, or your sales traffic you want to keep separated physically within the network. The departments allow you to do that. And these departments basically are carried, separated within a single shared data tunnel using MPLS tags, so that the data traffic does not actually mix between the departments. And if you want to actually connect the departments, you have to have an explicit policy at the hub to allow reachability between departments. Otherwise, the departments are completely separated out at every endpoint.
Greater than 25 is a little vague.
20,
that number could be 26 or 10,000. What's your scale limitation on VRF?
It's just it's a tested number. It could be higher.
You've done the 25. You don't have a theoretical limit, but
we could go much higher.
So there,
we could go much higher.
SRX, different models, you will see that they can have a different number of VRFs. Actually, those are very high.
Yeah.
I mean,
yeah.
But then that
Nobody
has
has
to be
more than
balanced
25
with
departments.
multi-tenant. This is actually 25.
I'm actually
single
funny.
tenant.
No. This is per tenant. So within the hub, you could have hundreds, if not thousands.
Right. So if you have on an SRX device, right, that number goes down really rapidly. If you're doing 5 tenants versus 1 tenant, the number inside would be different, right?
Right.
Yes.
Right. That's correct. Yeah. We also support user-based firewalling. So this is by connecting our firewalling capability to things like an Active Directory or an LDAP server. We can not only just report on IP addresses, but actual users within the reports within the SD-WAN system. So this is a pretty nifty capability for an enterprise where you want to segregate different types of users based on their organization or their work type, for example, like sales, finance, et cetera, and you can apply different policies to those users, and as well as potentially break those out types of traffic in various forms within the overlay and underlay environment.
See, that's the stuff I'm excited about Marvis seeping into.
Does it bother you that finance is allowed to watch YouTube and sales is not?
Marvis would be like, cut that out.
Exactly. Let me drop that YouTube traffic.
Yeah, right.
Exactly. We also support full unified threat management. So this is a key capability because, as I mentioned earlier, in a lot of cases, when you're breaking out into the underlay on the internet side, you need some kind of threat management capability, and we provide that integrated into the device. Without this, a lot of customers end up having to put a third firewall or a third-party firewall behind or in front of the SD-WAN device, and the networking part of it at every branch becomes quite complex very quickly. Whereas, in our case, the policies and the data path is truly integrated, so you can just break out and apply the policy right there within the SD-WAN device into the underlay internet as an example.
So let me wear my skeptic hat for a minute.
Sorry?
Let me wear my skeptic hat.
Okay, sure.
Because this slide reminds me a whole lot of when the SRXs first came out and all the cool things that we can do, just not all at once. And now you want to tell me that we have all these cool things that we can do, and we can do SD-WAN and talk to somebody else and encrypt stuff.
That's right. Yeah.
How many all at once?
So, I mean, I think, at the,
You're at less than 20, yeah, right, and VRFs, I forgot about that one.
I mean, as I started fair point, right? At the start of the session, we have a very wide portfolio of devices with different performance characteristics, right? So
my branch
clearly,
office
if
has
you
the
enable all features, I'm sorry?
I said, so my branch offices need to have the SRX 5600s?
No, you don't need to. No. But
As the sales guy's going, yes.
Almost,
Yes. But we've done baselining, to your point, and it performs to a reasonable degree with certain features on. Now, certainly as you turn on more features, there will be some impact, and that depends on the level of performance that you're trying to get. But we clearly have a portfolio that for all the different bandwidth types, so we can give you recommendations on when you're doing SD-WAN with some of these additional features, what is the right platform for you to pick given a particular branch size or capacity
In the
requirement.
different testings that you've done, has it gotten down to, not necessarily packets per second, but throughput with each of the features?
We have numbers where we can guide customers for IMIS traffics with SD-WAN, with NGFW, with full UTM, IDS, IPS, things like that. Yeah, absolutely.
Yeah, because that obviously becomes important in sizing.
Yep. Okay, so the other piece here is the multi-cloud aspect. So we also extend through this cloud spoke option into AWS today, where you can specify a region, a VPC ID, prefix, et cetera, and we automate a CloudFormation template that you can run within AWS, and that automatically enables the endpoint within your VPC to connect into your enterprise or provider hub and become part of that overlay network. So this seamlessly now you can extend that your SD-WAN network into public cloud as well. So that's the key capability that's there today.
Sorry.
Yep, sure.
So you just keep coming up with the cool things to add. Now this one I'm not going to pick on. This is just information.
That's okay. That's okay.
One, is there any plans on doing Azure?
Yeah, we actually support Azure today. It's just that they need some additional automation capabilities, which is coming in the roadmap. VSRX on Azure is fully supported today.
Okay. So second one down that path is, are you working with any of the FedRAMP providers?
Of the?
FedRAMP?
Yeah, so we are working with sub-partners to get the software into GovCloud, which is FedRAMP certified. Yeah, we actually have an ongoing project for that.
Okay.
Okay, so I think a couple of key last slides, and I'll hand over to Snehansu hopefully soon. So basically, we have very extensive multi-tenancy. Where we go through, not just the tenant level, but we have a concept called operating company, which allows separation of tenants. And then each tenants map into departments, which map into VRS, as I mentioned. So we actually have 3 levels of management multi-tenancy, and then we have 2 levels of data plane multi-tenancy in the hub as well. And this is all enabled on the existing portfolio. Right, and the existing SRX devices and NFX devices that are part of our WAN edge. So you can see all the numbers there. I think from the low end on the SRX 300 to the 4000 series, the NFX 150, the 250 series, and then it's also supported with our dual SIM LTE module, which is supported on the SRX as well as on the NFX. And then, of course, the VSRX piece for public cloud extension. Okay, so the key point in this is that whatever is the size or the type of deployment or the environment, the Contrail SD-WAN solution can actually extend into that environment to provide the needs for your broader enterprise and business. The other key piece here is with Mist, right? We worked very closely with Mist team to have backend integration. So we provide single sign-on to the Mist cloud today within the Contrail SD-WAN solution. So when a Mist access point is plugged in, it is automatically discovered. It's not automatically using LLDP, right? And then it becomes visible to the controller. Once it's visible to the controller, you're able to basically, the clicker is not working. Okay, here we go. You can click in, and basically we do context-sensitive cross-launch into the Mist portal for that access point, right? So that particular access point, you click on it, and you go directly to that access point in the Mist Cloud portal. And so that's available today as well to provide much tighter integration with Mist. And then we're obviously working closely to extend that functionality much more in future. In fact, what we are going towards, as at the start of my session, is to basically extend the Marvis capability, as you heard from Sudhir and Bob earlier, both across not on the Wi-Fi, but on the LAN as well as WAN, right? The SD-WAN controller gets a lot of telemetry on apps and users and IP address information and how they're performing. And we can very easily provide that information to Marvis, and that is where we're looking to go. That provides that single sort of pipeline and federated management view between Contrail SD-WAN and the Mist Cloud as well.
Is there any roadmap, or have you started down this path, or is it just not there to bring switches in as well? Because we're talking SD branch, which is different than SD-WAN. There's just an assumption there that means that it's extending into more of the wired and wireless access from a controller-based. Direction you're heading, or is that?
So we do support some basic switch management today as well. But as you saw, I think the switch piece is being led by the Mist team, right? And Contrail SD-WAN is integrating the SD-WAN solution to the Mist solution.
I think the holy grail here is the idea of being able to extend, VRFs and tenants and those things into the switching infrastructure as well at a branch. So the idea is that for a wired client to be able to connect the same way, because right now it's great that we have all this segmentation, but it happens right at the edge of the branch.
Sure. You're talking more about a campus environment. Yeah. No, we're looking at that.
Okay.
Now, that's supported on the EX4650 and higher switches. It's not supported on the lower end switches, so we are looking at that.
Okay.
Yeah.